So systems engineering approach to, so when I said providing PV, just so if I give you acronyms you don't know, please stop me, but PV is just photovoltaics. Photovoltaics is solar electricity, okay? So PV is just easier. Okay, and this is in Ghana, and it's called the Boko Bed Net Project. That's what it's called. Okay, you can go to the next slide. Or do I do it?
No. Rick, next slide.
Oh, Rick. Rick. Sorry. I thought Ann stood.
Who has control?
Somebody.
There we go.
Thank you.
Okay, so I'm not going to really read all the slides, but this one's important. So this project resulted in the evolution of the Boko Bed Net System. And it's for a malaria-ridden area in Ghana with no available power. So what we did was we looked at a problem, we analyzed it, understood the environment, and then looked for the right technologies to figure out a really great, simple, and elegant solution. To me, every time I do any kind of engineering work, the best solution is the simplest solution, especially something you can replicate. So the Boko Bed Net System, it's an LED light and fan, and it's powered by a small PV system, and it's located inside of a bed net. So the system is simple, but the project was really created out of need. Okay, so it comes from personal stories of malaria, cultural communication issues and taboos, and genuine compassion for trying to combat something as common and devastating as malaria. So I'm just going to tell you how this project started was I was president of the New Mexico Solar Energy Association, and after that, I've been on the advisory board since then. And that's called, the acronym is NMSEA, New Mexico Solar Energy Association. So NMSEA got a letter from someone asking for some help with this project. And this project's in Ghana, so I didn't answer it at first, and I'm really intrigued by any of the stuff that I can do to help overseas. And so I wrote this guy and I said, why did you contact us in New Mexico? And he said, I live in Albuquerque. Well, it turns out he is an American, and he has a surf shop in Ghana. He's a surf dude. You know, like, I want to say California dude. I don't know exactly where he's from, but, you know, he's a surfer. And he found this great place in Ghana. He has a surf shop. He's like a white guy from the U.S., ended up having this surf shop in Ghana. And in this part of Ghana, there's malaria. And so bed nets are available everywhere, and they basically cost so little that they're basically free to people. But they're not using them. And they're not using them because the weave is so tight that it's too hot to sleep under them, and especially during the time that you need to. So unconsciously, people are choosing malaria over using bed nets. They're not really consciously doing that, but that's what's happening. And so he came to us to say, this is crazy, you know, there's malaria, bed nets are available, people aren't using them. What can we do? What if we put, you know, his idea was, what if we put a fan in there? I mean, that's what they do in the hotels, right? They have air conditioning maybe, but where they put a fan in there so that people can sleep under these bed nets. And then he said, and as we talked about this problem, we thought, well, what about a light? And they can read under the bed nets also. So maybe they'll use them more. So that's how this project got started. Okay. Keep going. Rick. Here we go. So this is the outline of the presentation, right? All the things I'm going to talk about. I might skip around a little bit, but I'm going to try. Go ahead to the next one. Okay, so because I can't memorize this, malaria, I'll read it to you. Malaria is the #1 killer of children in Africa. Approximately 1 million people die from malaria every year in Africa. The annual economic burden of malaria is estimated 1% to 2% of the gross domestic product in Ghana. 3.5 million people contract malaria every year in Ghana, kills 20,000 children, and 25% of those are under the age of 5. So, and even if a child survives the consequences from severe malaria, such as convulsions or brain dysfunction, can hamper long-term development and schooling. So I can tell you a couple things I do know also about malaria is if you take Lariam, I think that's the main drug for malaria, you can take it for short terms, but it's really bad for you to take it long-term. There's a lot of health problems for taking it long-term. So especially foreigners that live in the developing world, lots of them just have malaria and deal with it because it's actually worse to take the drug over many years. So I worked in Vietnam and I worked in the Solomon Islands, and they didn't have malaria where I worked in Vietnam, but they did in the Solomon Islands. And I took the drug, I slept under a bed net, I was good. But, you know, to me the consequences were too severe, and I was there just short term. But I had that information from others that had spent significant amounts of time in the developing world. Okay, next slide. Okay, so I told you the basic deal is that the biggest challenge is people aren't using the bed nets, and even though they're basically free to them. So what we want to do is we want to give them a reason to use the bed nets. So what I did with this guy is, and how I work in systems engineering and how it relates to peace engineering and the conference that I'm at is, they can call it systems engineering or not, but in all of the talks I was listening to, I heard systems engineering concepts throughout. People understanding the requirements, looking at the problem, you know, trying to really define the problem and use many of the concepts that we have in systems engineering in solving the problem. And so, and what you know, and I want to get to this. So, what we wanted to do was, what we did was we started with, I told this guy, I said, okay, we're going to have a photovoltaic system. We're going to start with a photovoltaic system and whatever products we're going to use to solve this problem. And I said, but we're going to start with, we're going to get a bed net, and if the bed is on the floor, we're going to put the bed on the floor. If it's up this high, we'll put it up, you know, 5 feet off the ground, whatever. However people live in Ghana, we're going to set up a system to mimic so that we know that we're solving the problem. And we set it up, and I wanted to set it up in a place that was even hotter than where it was in Ghana. So we set it up in this guy's garage in Albuquerque in the summer, which is hotter probably than anywhere if you have the windows closed, right? So we set up a bed net. We put the bed on the floors where they sleep. And what we did was we looked at different, what kind of fan did we want to use and what kind of light did we want to use. And then how much power did it need, right? And we were going to build the system from that. So we started with, and I had worked in the developing world some, like I said, I had worked in Vietnam and the Solomon Islands, and I'm all about using local components. And so to me, I thought about what kind of fans are out there already. So there's fans, the fans that are in computers are everywhere. So muffin fans, things like that, are everywhere. And we could start with that. They're cheap, they're easy, they're actually, you could probably get them in a recycling place or in the trash dump, and you can get some fans. And you don't need a whole lot of air in the bed nets, right? So we were going to play with different fans to see how they worked, how they sound. Some were really loud. So we played with that. And then, I don't want to go too far without changing. So, yeah, I talked about this. Okay, you can go to the next slide. All right. So, yeah, the requirements was make it comfortable, add a fan, add a light, use local materials, right? And I like the idea of reduce the impact of foreigners, right? I'm all about empowering people to do the work themselves. That whole thing of if you give somebody a fish, they eat for a day. If you teach them how to fish, they eat for a lifetime. So if I solve the problem, I knew how to, I can do a power equation and I know how much power to give somebody. But if I teach somebody how to do it, then they can do it also. If we can figure out a system that works and we can transfer that technology to the local people, they can do a lot more with it and we can empower them to help themselves. Okay? So I have very big issues with us in the developed world going into the developing world. We are high maintenance people. We take up a lot of room. We are very demanding, and it doesn't matter what people say. It's very true. And it's better if we get in, teach somebody else how to do something, and then get out of the way. because I'm telling you, we take up a lot of room and we are very high maintenance. And we demand a lot, which is insane when you're in the developing world. Okay, so I'm all about teaching others, empowering others, creating industry, and creating revenue for them as opposed to us. So our model often is to go into the developing world and get people addicted to whatever we want to get them addicted to. Our power, our technology, our gadget, our whatever, right? Okay? And then we had to make some decisions, right? Are we going to make something, or are we going to buy something that make instead of buy? You know, are we going to customize it? So I also have issues of providing something that we make specifically for somebody. If we don't maintain it, have parts, can support it, all of those things that are systems engineering, maintainability, reliability, supportability, all of those things, right? So if we can use local products that people can just find anywhere, that's the best way to do it. Oh, I need to say something. These pictures here were made by people in the village in Ghana. And they were used to teach this to each other. So all of the pictures that I put in here were actually used in the teaching of the locals to the community. So I thought that was really cool. Okay, next. All right, so critical design elements. It has to be simple, inexpensive, reliable, and it needs a renewable power source. There's no power in this area. Okay, so using photovoltaics is the way to go. So we conservatively estimated that the system would be on for about 7 hours a day. It's hard to know, but that's what we estimated. And this was going to be using about 3 LED lights and a fan. So instead of using a sensor to turn the fan on and off, they used manual switches. At first we thought, well, we'll have it turn on and off automatically, but that's really too hard. And it's hard to get people used to that. And you know what? Even in the developing world where I've worked, if there's a way to override the system, people will do it. So, so you have to think about that too. So having manual switches and teaching people that, think about solar electric is, we have a battery also, so we're charging the battery. And if you have a control on the system, which we didn't, but if you have a control on the system and that turns it off, a lot of times you're discharging the battery too much. Because the people who design those control systems, I don't know how else to put that, they don't think that people can think for themselves, and so they don't let you, most of the time, especially with small systems, they don't let you change the settings. And so by using the controller as an off switch, it usually tends to discharge the battery too much and reduce the life of the battery. It's better to teach people how to use the system and actually believe that they can learn and use it and teach others. Okay, so, and I didn't quite talk about that. So in a solar electric system, basically the photovoltaics are just battery chargers. That's all you're doing in an off-grid system. You're just you're charging the battery. And what you want is you need to understand, and that's where I didn't go through the calculations, but we did, is you have to understand how much sunlight is available on average, how many hours, you know, how much power this thing is using, how many hours you're using it, and you want to make sure it's like a bank account. You can't take more out of the battery than you put in each day. So you got to make sure that you're putting enough power in, and then you size the system for what we call days of autonomy, and that's days without sunshine. So you need to have all of that into the calculations. And so that's the stuff that I was working on with this guy. And that's the information. I mean, ultimately you want to translate that information to the local people, but what you're doing is building a system that's robust enough that they can build many of them and give them to others. Okay? But that's what goes on behind the scenes. Okay? So we used a rechargeable motorcycle battery because motorcycles are available all over the place there. So we used local, as much local as we could get. Okay? There's more motorcycles in the developing world, especially that part of the world, than cars. Okay? So we balance the system and it doesn't use a regulator or charge controller. So a charge controller, all its purpose in life is to do is to make sure you don't overcharge the battery. And it has something called a high voltage disconnect. Just charging your battery all the time and make sure you don't overcharge it. And in many charge controllers, not all of them, but in many, they also have something called the low voltage disconnect. So that's the off switch I was talking about. And many of them are located together. Sometimes you have to buy one, you have to buy two pieces of equipment. But one piece is to make sure you don't overcharge it. The other is to make sure you don't pull too much, too many amp hours out of the battery, okay? So that's what it's doing. Okay, we're good so far? All right. I am not up with my stuff. I guess I don't need this. All right, next slide. So the system's design. So, we went through all of this. How will it be used? What are the parts that we need? How are we going to construct it? Where will we place it? All these things you have to go through. There's lots of questions. These are just some of them. What are the skills of local people, and how can the system coincide, the skills with the local people in the system? So in the middle of, so I'm going to kind of go off the slides for a minute and tell you the story. So while I was helping with this project, I never went to Ghana, like I said. But the guy that I was working with, he and others went to Ghana. So in the middle of this, I also actively worked with the American Solar Energy Society. And I was chair of the Solar Electric Division at this time, and so I was helping put together the conference. They do an annual conference every year. And I was reviewing technical papers. And so at the conference, I guess I went to the conference while I was doing this, and one of the sessions I was chairing, this guy was talking about making photovoltaic modules, small photovoltaic modules for helping folks in the developing world. And he was specifically doing, well, actually you can do any size module, but he was specifically doing cell phone charging. Because a lot of the world, if you do know or not, is a lot of the world got bypassed with landlines and went directly to cell phones, especially the developing world. And so a cell phone charger, everybody in the developing world pretty much knows that a cell phone charger, a photovoltaic cell phone charger, is valuable because you can just put this thing in the sun, you make a tether, you keep the phone in the shade. You don't want to make it too close, right? The phone's got to sit in the shade because you know what happens to a hot phone. It won't charge very well, won't work very well, all those things. And this is Ghana. It's also very humid. So you want to keep the phone in the shade. You want to put the module in the sun. So if I say panel or module, it's the same thing, okay? PV panel or PV module. So I meet this guy, this old curmudgeon-y engineer. His name is Dr. Richard Comp. Sadly, he just passed away recently, but he was great. He kind of invented everything, one of those guys who invented everything. But what was really cool is he took this incredibly complicated technology and he made it really simple. And so what he would do is he would get cells from China, seconds, because it doesn't really matter. And he would get photovoltaic cells and cut them and make small modules that was the exact right voltage for a cell phone. Okay? So if you can actually match the voltage well and how much power something needs, you don't need this extra piece called a charge controller because now you're not overcharging your device. Got it? So it's really a much more simple and elegant system, and you're eliminating a piece of equipment that can fail on you, right? It's a piece of electronics that can fail. Every time you can eliminate something, good for you, right? So when I heard this talk, I thought, I was telling this story today to somebody else, but I said, the guy I was working with, the surfer guy, his name is Peter, and I said, Peter, we didn't talk about my fee, but this is my fee for this, for helping you. And I said, this guy spent half his year in Nicaragua at the university there, and half the year in Maine, which is where he lived. And I said, you can go to Maine and learn how to do this, teach me. You can send us both to Maine, and we can both learn. Or we can just bring him here, and we can do some workshops and teach others, and we can probably pay for his trip. And that's what we did. And we did that a couple times. And he was the one that went to Ghana with them when they did this project. So he taught us, and so that's great, because now I know how to do it. And even though I was working at Sandia, and I had made some small modules, we had some laminators there, because when you make a photovoltaic module, you're actually fusing things together. In this case, it was really low tech, and they didn't need high-tech stuff. We could make a module by soldering some cells together. We could take some silicone and put it in a frame that you can get at the dollar store. You know, you can really do it low tech. And you can even get some catalyst material to kind of fuse things together and then use some bricks. And anyway, there's lots of ways to do things that are much more low tech when you don't need such a high tech solution. And that high tech solution they can't afford. There wasn't even a way to do it. So the module, if you look at what a photovoltaic module costs, even a small like 5-watt module, it's way outside the budget that they can do. But they can build it themselves. They can make it low tech, and if they need to replace it, it's really cheap to replace. So you can get cells for pennies. I mean, it's very cheap, especially the seconds. Okay, so, and when you know how to use the technology, when you cut up the cells, so in general, a photovoltaic cell is about 0.5 volt. And the size of the cell changes the current. So it's very cool and easy to figure out what you need. It's about right. And then you can take a meter and figure it out, right? And soldering, I really kind of suck at soldering, but other people are a lot better than me. And the local people are a lot better than I am. I can tell you that. So just to tell you that it became a really easy, elegant design, but eliminating that charge controller was really also made it a lot cheaper and easier to maintain the system. Okay, so what did I miss? Okay. Keep going. Next slide. So modeling the problem. We did a lot of work on calculating the amount of power that was needed. At first, we didn't know how much power was needed because we didn't know what we were going to use. So I oversized the system. So when we put the system here in Albuquerque, we got a module that I knew was big enough but was more than we needed. We got some lights. We actually started with compact fluorescent lights until we went to LED lights. And I haven't even got to that part yet. And then and we haven't talked about, okay, so I'm going to stay on this slide for a minute. And then, so here we have, now we have a module that actually we can tune any size that we want to fit how much power is needed with the system. The other part is I went to a workshop locally with this young guy who was making LED lights. Perfect. They use very little power, like 4 watts. I mean, they're tiny little bits of power. You don't need much light to read under a bed net. So that was another piece. I can tell you at the end of the day, we could take enough materials for 50 families for them to make this stuff themselves in 2 suitcases. Mm-hmm. Think about that. It was awesome. So we really, really were able to tweak the system. So I started with a bought photovoltaic module. We got down to something that we made that we were able to tweak to make actually work with how much power the system needed. And then we also decided to use a motorcycle battery because we also didn't need a whole lot of power. And we knew that we wanted a little bit of days of autonomy, but we didn't need that much. And at the end of the day, if they really couldn't read in it, we're okay. You know, it was kind of, we were hoping it could be, we needed to kind of see how the system worked and long term. Mounting the system, that actually went through some iterations, including while they were there in Ghana. And so what they ended up using, and one of my suggestions was to mount it on rebar, because rebar is also available everywhere in the world. They use it to build everywhere. So what they did was they were able to take some rebar and, you know, kind of manipulated it, and then put the fan and the light together on the rebar so that they could have it inside of the bed net. So what they wanted was they didn't really want to rip the bed net. I don't know if they had to make a hole in it for the rebar, but they wanted to minimize obviously the holes in the bed net for the so that they didn't have any mosquitoes. Okay, so everything that we could get over there, we got over there. The switches, they had soldering irons, they had the frames. They were able to get the frames there. There was very little. I think we only brought the cells and the LED, just strings of LED lights to make the lights. Okay. Let me know if you have questions as we go. Keep going. Next slide. All right, so as I said, we reduce the cost by customizing parts, right? And we customize as little as possible. We only customize the module and the LED light. So really, at the end of the day, the skills that the local people needed were cutting cells and soldering them, putting them in these frames, making the modules, basically. They made, one of the cool things that they did is they took that guy, Richard Comp, Dr. Comp, who went over there. What he did was he built these bigger modules at first so that they could actually run the soldering irons. It was great. It was like, they just did it all on renewable energy. It was great. So they figured out what they needed in order to build the systems, and then they made smaller modules for the system. Yeah. Oh, and they also made some cell phone chargers for folks because people really wanted those. They made a couple at first, and people coveted them and took them and, held on to them, and we didn't really want that. We really wanted people sharing information and sharing stuff, so they made a lot more cell phone chargers too. Yeah, because people don't understand, if you've never had power in your house, you don't really know until you get it, and then it starts to change the way you do things, right? But if you already have a phone and you already have to walk or travel or pay to charge your phone, it's a big difference if you have a cell phone charger. So that really enables and, empowers folks. And we transferred the technology to them. After a little while, Peter, so Dr. Comp would cut the cells and show you how to cut them. And I can tell you that I broke a bazillion cells. I don't know if you've seen a photovoltaic cells, but they're just very, very thin, and they're easy to break. They're almost paper thin, and they're really easy to break. So Peter could get them cut in China, already cut, and that saved a lot of breakage. So as they continued to refine the project as they went. Okay. So the training that they needed was really just the soldering and putting the systems in, manipulating the rebar, which several of them knew already, and there was always continuous improvement going on, right? So that's another part of Lean Six Sigma, but it's systems engineering, it's all of that, right? Okay? And so, like I said, we set up a mock system here, which worked just fine, right? Okay, next slide. So we used local materials, like I said, to reduce the cost. So what was available locally? Rebar, muffin fans, motorcycle batteries, solder and soldering irons, wires, switches, metal for mounting the structures. All of that was local. So everything that you can use. So all they brought, isn't this great? Just PV cells and strings of LEDs. I just thought, that's the way that I want to do engineering, always. Make it simple, empower others, get out of the way, give them a way to empower themselves and make money and improve their own stuff, their own community. All right, next slide. So logistics. Okay, so take the manufacturing. So the point was to transfer the technology. Okay, so figuring out how many systems they needed, parts that were available, how affordable are they, right? What skills existed, what needed to be done. Luckily, this guy had been in this area and had a good idea of what was there. But this is a continuous improvement project. Teach people what they need to learn, and capitalize on what people already know, and have people teach each other. So the systems, so how this worked was it got funded by doctors that wanted to eradicate malaria. So there's a lot of money out there for that. So that's how this project got funded. And so what they did was, which was also very cool, was they had a nurse go, I think she was a nurse locally from here, who went and stayed there for a while, but interviewed every family before they got the bed net system, so they would have a baseline study, then they would give them the system, and then they would do a follow-up study afterwards. So that was also part of this. And the baseline study was Do you have malaria? Do you know what malaria is? You know, do you sleep with a bed net? Do you have a bed net? You know, I mean, whatever. These are really basic stuff, right? Do you have one? Can you afford one? Do you sleep with one? You know, how often? How do you use it? Whatever. So there was a real baseline today because they wanted to understand what was going on first and if this would help cut down on malaria in the area. So it was a great win-win situation for everybody. So they were able to get information. We were able to help the community. And how many systems did we, so I think they had 50 families. So that's why I said they were able to take everything within 2 suitcases. It was great, like small, not even big suitcases. And this was very affordable for them. So they were able to do a payment system with people that needed to do it. They figured out what the cost would be. They continued to reduce the cost, but what is the cost? How much can they afford, and how do you want to make it happen? Because you know what? If it's $10 and you don't have $10, it doesn't matter. You can't have it, right? You can't, you know, if the system's unattainable, it's unattainable. So you have to make it within the reach of the people there. Okay. Oh, and when they were leaving, these folks were actually setting up a warehouse so that they could make parts, you know, get parts, and not only just make systems for the bed nets, but also make cell phone chargers, which were really valuable in the area, and that was a really great way to make money, and they could educate themselves. It's another way for people to have jobs, stay in the area, all that stuff. So there's a lot of things that get affected, even in one project. Okay, next. All right, support and training. So the idea was to transfer technology, train local people to make the modules, the LED lights, and assemble everything. Okay, so the project success, like how do you measure success, right? You have metrics, right? Will be when the transfer of technology from the team to the local people. So train them to build their own modules and LED lights, and this is where they can learn new skills, start cottage industries, etc. So the team trained local people to build, like I said, both cell phone chargers and modules. And the cell phone chargers were already high in demand. As soon as you have one, people are like, I want that. If you know what it is, they want it, right? So, and they trained 15 people. Initially, they trained 15 people in the village to build modules and cell phone chargers. So and the age range was from late teens to about 30. That's just some of the statistics I have. Okay. Keep going. I probably need to be done really soon, but maybe you have lots of questions. So implementation. So like I said, a team of doctors, nurses, and professionals went to Ghana in 2012 on their first trip. So over 90% of the 60 homes in the village of Kitakro, I can't even pronounce it right, they have thatched huts, mud walls, and they still cook with collected firewood. So those are the things you need to know before you go, like what is the housing stock like, right? Where are you going to put this thing? How are you going to mount it? Where does it go? You know, all those things you got to know. So one of the tasks for the team to choose the first 10 houses and determine which workers in the village would learn how to do this, right? The team and the people from the village installed the first 3 systems, and the next 2 were installed by the local people. And the final 5 systems for the first phase were installed by local people. So the whole idea was transfer the technology, make sure, you know, supervise that, keep transferring it, make sure it's working, right? You want to make sure it's all about reliability, maintainability, and you want to have quality all the way through. As much, you know, as high quality as you can get. Okay, I don't think I have much more. Next slide. And this is my last slide. Hold on. Oh, nothing else. All right, so there were 2 teams connected to the project. One was the doctors that wanted to eradicate malaria. The other was the team that were helping do the implementation of the technology so that people could use the bed nets to also, you know, to help the eradication of malaria. So there were healthcare workers, and then there were the project workers. That's what we called it. So the healthcare team concentrated on the baseline study and tracked that aspect. And the project team built and installed the systems and the lights and transferred the technology. So they had to work together, and they both added value. So that's another thing. These were two teams from the U.S., right, going into the local village, understanding the culture, knowing some of the language, whatever, making sure that you have that or you have someone to work with you through that is really important, right? Having technical people on all aspects of the project to help legitimize it, attract investors, right? They got more donations to continue the project. So that's another thing. How are you going to continue this? Where are you going to get the funding? How are you going to do it? Maybe the sale of the cell phone chargers will help perpetuate that because you want it to be sustainable in its own right eventually, right? Okay. So those were the two very different teams of people. And, you know, the healthcare workers don't know anything about the technology. And the folks like myself, I don't know much about malaria except I don't want it, right? Okay. I'm going to sleep under a bed net and take Valerian while I'm there if I was going. Okay. Next slide. So, summary. So they call it a Boko Bed Net System. That's what they did. They called it a Boko Bed Net System because it is a system. So it became a viable economic option. So it allows the communities to locally make, install the fans and the lights, and it was powered by a renewable energy source. So it was all very sustainable in its own right. So there's a team of dedicated, knowledgeable professionals came together. We looked at the problem statement, we executed a plan, we designed, we tested, we installed, right? We trained local people, and we taught them how to assemble and install it themselves. So, you know, I think that's successful, but it's more successful if it's long-term, if it's kept going long-term. So bringing power and light to a region without power doesn't mean it can change people's lives. I worked in Vietnam and brought power to people. So I worked in Vietnam and the Solomon Islands and brought power to people for the first time in their lives. I mean, it changes their lives. And I don't know what they used in Ghana, but I'm assuming they use kerosene. And if you've ever tried to use kerosene, does any of you? Okay, so I have, and I have asthma, not a good thing. It's really nasty. First of all, you know that it's really flammable and very dangerous. Right, they had that whole thing, was it years ago when the cow kicked over the kerosene lamp and homes would burn down like that, right? So it's still the poor people's light. It's very bad light. You can barely see, gives off tons of smoke, tons of respiratory problems, still in the developing world from kerosene. So it's not a good option. This is a way better option, much cleaner. LED light's great. And it's getting better all the time, and it's gotten a lot better since we did this project. So, and there's, you know, as I said, as I alluded to, so there's special considerations when working in the developing world. So language, travel, spare parts, tools, permission to go, right? I have to tell you this. I only work on projects if I have champions with me. If I'm working really hard to get doors open, then I'm not interested in doing it. There has to be people that also want to help themselves and work with me. You know, if I do it in the U.S. or if I do it other places. Like, I've done lots of projects at schools, and I'll work with schools that work with me. Or I'll work with nonprofits that work with me. But if I have to start, you know, if doors are closing everywhere and people are not participating, what's the point? Because that isn't a sustainable thing. I'm going to put a system in, and I'm not going to be there forever. I don't care if it's down the street from me. I'm not their electrician forever, right? So people have to there has to be some kind of buy-in from whoever you're working with. And I suggest that to anybody who's working in the developing world. You need people, you need champions, you need sponsors, you need funding, maybe all of that, but you need people to work with you, and you need them excited about the project, and then it's really exciting. And it's empowering, and it changes people's lives.